Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi, and welcome to GeeksforGeeks. Today we would be doing the post-contest analysis of 98. So before we move forward, let me introduce myself. Hi everyone, I am Siddharth Hazara. Currently, I'm an SD at GeeksforGeeks. Beside them, I'm also a candidate master on code courses. So before we move forward, let us, without any further ado, let us just move forward to this. So, can I have a quick yes or no that I'm visible or not? Just a quick yes or no. Hi, Ravindra Singh Roy. So let's talk about the views towards the problem of this contest from me. So my personal view would be that the first problem was very easy, kind of, like it was very easy to guess. The second problem was a problem which would have involved um, complex algorithms such as multi-source BFS. But as the constraints were very less, so you can move forward with brute force. So first problem was just a little bit of thinking, an easy sort problem. The next problem was analyzing the constraint, and the last problem was using the knowledge of graphs. Like if you are already familiar with graphs, if you already know the topological sorting and all, then you can move forward. The second was inspired by N Queens. No, I don't think so. It was inspired by N Queens. Why? Because N Queens uses the algorithm of backtracking in the backend. But here, this problem does not use backtracking in the backend. It is a simple brute force solution. Second question gave wrong answer in one output. Can you tell me the inputs? Okay, so let us move with the very first problem. Yep. What is the output of this? The output of this is, oops, sorry, I just copied the wrong one. Internet connection is the problem, second one. Yep, this is the very first problem. Sorry about that. Okay, so see, in this problem, we are asked that for a particular item, there can be prices. Like for suppose, I went to the market and let's say I want to buy potatoes. Okay, let's say, and the price of potato for 1 kg at one market is 5 rupees, and in the next shop it is 10 rupees, and in the third shop it is 15 rupees. So I want to know that what is the minimum price each item should be bought. Okay, so I have a list of items that I need to buy. So list of items are 1, 2, 2, 3, and these are the prices of each of the items. So the price of the first item is 3. Okay, so first I went to the shop and I found a pricing of 3 for the first item. Then I went forward and I saw the pricing of the second item, and the pricing is 4. Then I again saw the pricing of the second item, which is now 5. Okay. Then I saw the pricing of the third item, which is 6. So as the item 1 and 2 is only available on one shop, we don't have any alternative but to buy from that shop. But 2 has an alternative that we can buy from 2 shops. And if we want to minimize the amount that is spent, then we should buy from this shop because this shop offers me a less amount. So for buying the second item, I would need a price of 4 for buying the third and the first item, and it is only available on the first only one shop. That is why the solution would be 3 plus 4 plus 6, which makes it equal to 13. That is why the output is this. So give me a quick one if I make sense with the sample input and output. So there are many questions similar to the second question on lead code. Might be the scenario. The first question was pre-solved in Java. Okay, pre-solved in Java. Okay, let me just take a screenshot of this. Copy to clipboard, and then let me just send it to the team. Okay, told to the team. Anything else? And third question was so incorrectly written. To be honest, the third question was the sampled input test case was not even mentioned. I just told the sample test case. Okay, I'm clear with this. Okay. So now what we can do is for each of the item, we can just assign it with the minimum number. For each of the item, we can just assign it with the minimum number, and that would be good to go. Okay. So now what I can do is I would say first this is item, so I would just say A, and this is price, so I would say P. Okay. So now I would declare a map of int comma int m, and then first I would initialize everything with, like, what I can do is I can just initialize it for for int I is equals to 0, I is less than n I plus plus. So if I have, like, this is the first time we are seeing a particular item. Okay, if this is the first time, if m dot find is equal to m dot end, that means that this is the first time we are seeing this item. First time we saw this item. If this is the first time we saw this item, then we would just save whatever value is given at that point. So m of a of I is equals to p of I. Simple enough. Like suppose I am the first time that I'm seeing of this product, so I would buy it whatever shop it is present. If that is not the scenario, then m of a of I already has some value. So m of a of I is equals to minimum of whatever was already there and the current pricing. After this is done, we would just iterate on for auto dash a comma b dash m, and we would just add the pricing. So I would just say int answer is equals to 0 and answer plus is equals to b. Okay, and then we would return the value of the answer. Now let us just see. Yep. Let us try to submit this and see if we can get an AC or not. Okay. Let me just see what was the mistake I'm making. 10 to the power 3 P of I. Um, so basically, this online compiler gives a correct verdict on unordered map, but it should have also given a correct verdict of map also. Y 10 to the power 6 multiplied by log base 2 of 10 to the power 6 is less than 10 to the power 8. But beneath this problem, they use some test cases and all. That is why this is not giving an AC. But try to avoid unordered map as much as possible, because the worst time complexity of unordered map is big O of n, not big O of 1. Okay, so now I would just present my screen and you tell me the point at which you are not able to understand. So this was anti-collection. Yep. So now tell me the line number at which you are not able to understand. I used the same concept, but it was returning zero to me. To be honest, I solved this problem very randomly. Like if you just see the summation of mine also, I didn't submit it before if you observe. This is the first time I'm submitting this. So I didn't do anything other than this. I solved the problem just by the very dynamic way. I saw this problem here and solved this problem live itself. So now tell me the point at which you are not able to understand. Just because of using map, I was unable to submit it. Why you were unable to submit it? Can you tell me? Why wasn't it working for int with this line? Don't know. It might be some compiler issues or something. Like let me just see. Int a dash c comma d, because I think I have already declared a. So now let's just add d. I realized it a little bit late. A is already declared for this vector. Unqualified ID auto. This should work now. D was not declared in the scope. Expected B before this. Don't know, bro. Why this is giving me a problem. Line number 38. Okay, line number 38. What is it? Let me just see. Because suppose I want to buy suppose I want to buy brinjal. Okay, I want to buy a brinjal and I saw a shop which sells brinjal at 10 rupees. So this is the first time I saw brinjal at a store. So I would keep in mind that yes, 10 rupees is for this brinjal. So I would keep in mind with her. Okay. So I would save up this value. So when we are first seeing up something, we would save up that value. And when we are seeing that value for the next time, we are taking the minimum value. Like translating the same in Hindi would be like, suppose पहला बार कोई दुकान में 10 रुपए का दिखा, so we are just taking it for 10 rupees. दूसरे दुकान में let's say 5 rupees में दिखा, so मुझे अब पता चल गया कि मुझे ये आइटम 5 rupees में लेना है. क्यों? क्योंकि minimum of 10 and 5. That is why when we are seeing an item for the very first time, we are just taking it as it is. But when we are seeing it again, where we are comparing that it is the minimum time or not. It is just like that translating, like let us take an example that when we are first time in a relationship, we do all the mistakes. But when the next time we get into a relationship, we try to avoid the mistakes. So first time we are accepting everything. When the next time we are saying it, we are taking the minimum value out of it. Please solve this using Java. Okay. Someone please help me understand. I am a beginner here. Like what you want to understand? Tell me the line number. Okay, I have done similar but was getting TLE. Same code I'm submitting twice. So please solve this using Java. Just use hash map instead of an ordered map, and that would be done. Most welcome. So I deserve a chocolate from you, Sachin. So now the very next question is a good one. So now see this problem. Oops, I just added to the same page. Yep. So this problem tells us that there is a range, like this is a given matrix. So this is 0, 0, 1, and this is 0, 0, 0, and this is 1, 0, 0. And it is telling me that each Wi-Fi has a range of 2. Okay. So 1 represents Wi-Fi. So 1 represents Wi-Fi. Okay, 1 represents Wi-Fi, and that Wi-Fi would produce signals in 8 direction like this. So this one would, if the range is 2, in this direction it would be giving the range to this. In this direction this would give me the range to this, and in this direction it would give me the range to this. Okay. Okay, range is 2. Does that mean that range is 2 means range is 1? Okay, range 2 means that value plus the current value. So range is 2 means that these two would be converted, these two would be covered, these two would be covered. Now for this Wi-Fi, the range would be 2, the range would be 2, the range would be 2. Okay, so as you can see that this is not covered by either of the Wi-Fi. So if the range is not on all of the figures, then it is not correct. Okay, so you can just, let me turn this phone in the silent mode. Yeah, so you can say that each Wi-Fi is producing radiation in each direction and it has a range, and if it is not able to cover all the position in the matrix, then the value would be false. If it is able to cover all the position, then the value would be true. Oops. Oh. For unordered map, the time complexity for all operation is big of n. The worst time complexity. Yes, it is. Many people don't know it. Not an as an emoji. Send me in person. Okay. So the board is not visible. Someone even called the phone to tell him about screen. No, 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 no. Like it was my school friend who didn't knew about who didn't knew about this. Like the name of my friend is Rahul, so you can just see it. I'm not telling a lie. This person called me, so he is my old friend. He didn't knew that I was just doing some stream or something. Share the window. Yes, sorry about that. Okay, so let me draw it again then. So it is telling me that we have an matrix. Okay, we have a matrix. Okay, we have a matrix 0 0 1, then 0 0 0, and then we have 1 0 0. Fair enough. So now it is telling me that each one is a Wi-Fi. So one represents a Wi-Fi. Please remember this. Now it is telling me that every Wi-Fi would have a range of 2 in each direction. What do you mean by each direction? Each direction is top and bottom, left and right, and this. This is 8 direction. So now if you observe, I can just traverse this. I can traverse this. I can traverse this. I don't have anything here. So for the same thing, if the range is 2, I can traverse this. I can traverse this. So let me just change the color so that people would have a better understanding. I can traverse this. I can traverse this. I can traverse this. So that is why these two values, like these two range, is not covered by the all the Wi-Fi. So if any of the position is left which does not have a range of the Wi-Fi, then the value of this would be false, else the value would be true. Do I make sense? Give me a quick one. So see this thing, like see this, like I found this now. So it is telling us okay, see this 1 0 0 1, and the range is now 2. So for this Wi-Fi, I would be able to do this, I would be able to do this, I would be able to do this. Okay. And for this Wi-Fi, I would be able to do this, I would be able, so every range is covered. So the output should be false. So output should be true, not false. So this test case is wrong. But we are given at this point that hence we return true. It is telling us that we are returning true. But by mistake, the problem setter has written false in the output. Okay. So I found this funny up here. So are you able? So range is equals to range minus 1. Okay. What is range? I'm also a DA, so I'm also a DA. So basically, no, I'm not completely from DAV. Basically, I belong from a Christian school. Like till the 10th standard, I was in a Christian school. But after 10th, my mother, like I started doing a lot of problems in my home. So my mother told me that you took take admission in my school. So my mother is a teacher in DAV. She is still a teacher in DAV. So I took admission in her school, and this person is my old friend. Okay, though this Wi-Fi including the area of Wi-Fi location also, yes, absolutely, absolutely. Suppose this is range 1, this is range 2, this is range 3. So this also tells me that this is range 1. If the range is 1, then it would cover itself. If the range is 2, it would cover this. If the range is 3, it would cover this. Okay? Do I make sense? Range is passed in one function. Okay. So now, let us analyze this. Okay. So what would happen if we just solve this problem very lamely? Like for each of the location, we mark all the range. What would happen? So there is a very interesting thing to observe that the range is only 4. Okay. So for one position, we would be moving at most 4 times, like 1, 2, 3, 4. And this can happen in 8 direction. So for one location, if it is a Wi-Fi, so for one location, if it is a Wi-Fi, we need to mark 8 multiplied by 4, because if the range of the Wi-Fi is 1, then it is 8. If the range of the Wi-Fi is 2, it is 8 multiplied by 2. If the range is 3, 8 multiplied by 3. So for one location, I need to mark 8 multiplied by 4 location. Okay. So if everyone is a Wi-Fi, that is that the number of cells are 400 multiplied by 400. Why? Because the value of n is 400. So in the worst scenario, this many cells I would be marking in total. So now let me see if this is feasible or not. So 8 fours are 32. 32 multiplied by 4, 400 multiplied by 400 is less than 1, 2, 3, 4, 5, 6, 7. It is less than 10 to the power, like let me just copy, like let me just keep this here. And this value is less than 10 to the power 8. So if we implement this correctly, we would get a, we won't get a time limit exceeded, but we would get a AC. That is accepted verdict. Okay. So even if everyone is of Wi-Fi, and even if like the size of the matrix is 400 into 400, still we would be able to do it in less than 10 to the power 8. That is why we can move forward with brute force. So after analyzing the constraint, we can move forward with brute force. But if this was like the range was much greater than 4, then we could have used multi-source PFS. So am I clear till this point? What does it mean range is equals to 0? If the range is equals to 0, that means even that value is not calculated. Am I clear till this point? Just give me a quick 0 or 1. Give me a quick 0 or 1. Okay. Anyone for whom this thing is not clear, give me a 0, else give me a 1. So there are more than 50 viewers at this point of time. Divyanshu, can you tell me the point at which you are not able to understand? At this point, we have more than 50 viewers. So let me just check what is the number of like. I will just try to balance the likes. So quickly like the video. Quickly like the video. It is just 20. Can you quickly like the video? It's done, Divyanshu. Without me even explaining you understood how to specify the range. Do code of multi-source BFS 2. This is an online judge, so our main aim is to just surpass the time limit. Please tell us optimized approach also. Okay, I would tell you. But first, I would just code the simple solution. So for each point, we would go in all the 8 direction and we would just submit this. Okay. Now, so more moving in the 8 direction, there are 2 ways. Okay, either from one direction, this is 0 0 0 1 0 2, this is 1 0, this is 1 1 1 2 2 0 2 1 2 2. So see, if we move in this direction, it is x-axis plus 1, y-axis plus 1. It is x-axis minus 1, y-axis minus 1. Okay, and this is x-axis minus 1, y-axis plus 1. So instead of doing this again and again, x-axis plus 1, y-axis minus 1, and writing if statement 8 times, we would just declare dx and dy. Okay, we would just declare a dx of dy. Dx is equals to of size 8, where it would be 0, then 1, then 1, then 1, then 0, and then minus 1, and then minus 1. Okay, this is dx, this is 0, 1, 1, and then again 1, then 0, minus 1, minus 1. And then we have dy, which is also equal to 8, and we would just kind of copy this, just the opposite of that. Okay, which is 1 1 0, and then it is minus 1, and then it is 1 1 0, and then it is minus 1 1 1 0 1 1 0 minus 1, then again minus 1, then again minus 1, and then again 0. This would be 10. Yep. So what is this all about? Let me just show you this also. Suppose this is suppose this is 0 0 0 1 0 2. This is 1 0 1 1 1 2 2 0 2 1 and 2 2. Let me just change the color of this. Yep, see. So if we are moving in this direction, so this is 0 1. So if we add 0 1 to this, what would happen? 0 1, that would, it would become 1 and 2. So we are moving here. See, this is 0 1. If we add 1 1, then we would go to this. 1 1 is done. If we add 1 0, okay, if we add 1 0, then this would become this. This is done. If we add 1 minus 1, that is 1, that 2 0, okay, we are moving in this direction. If we are making 1 and minus 1, that is 2 and 0, okay, so we are adding 1, that is 2 and 0. So do we have 2 and 0? 2 and 0, yep, this. Then 0 and minus 1, so we just visit this. Then we have minus 1 1 0 0. So this would be again 0 0. This would be 1 1. This would be this. So we are moving in all the direction by using this. Okay. So let me just verify this also. Like I have written this correctly or not. Okay, let's just submit this. If we get a wrong answer, we would verify this. At this point of time, let's not verify this. Let's wait for the wrong answer verdict. This is 0 1. This is 1 1. This is 1 0. This is 1 minus 1. This is 0 minus 1. This is minus 1 minus 1. This is minus 1. This is minus 1 minus 1. This is minus 1 0. And then we have something like 1 2 3 4 5 6 7. So last one is remaining. That is minus 1 and 1. Yep. Okay. This is done. Now, what we would do is we would have a visited array. So we would say vector of vector int. We would just declare a 2D array of visited. Okay. And we would say visited array of n of vector int of size n again with everything as 0. So we are just declaring, like, what are we doing? We are declaring visited array of x, like n cross n. We are just declaring visited array of n cross n with every value as minus 1. But we are doing that in vector. Okay, this is basically this thing. Now we would start the iteration. For int I is equals to 0, and then I is less than n and I plus plus. Okay, someone wrote here, सारा time खराब हो रहा है. So you don't know the solution and you came here, so you are learning here. But I already know the solution, I am explaining here. So if this time frame, like the wastage is more of mine than a student. And please consider that I am also a human like you. Please consider this. ये थोड़ा सा informal लगता है, थोड़ा सा. Like ये सारे comments for a future SD or for a technical role, these all comments are not expected. Please understand. Okay. Sorry. I would repeat again. Why so worries? इतना छोटा ही कोड लिखा है, क्या होगा? फिर से explain कर दूंगा. I'm not getting irritated. Why are you getting irritated? No? I'm also human like you. So see, I would keep the screen sharing on for the rest. Like I won't remove the screen sharing now. You see, this is 0 0, this is 0 1, this is 0 2, and this is 1 0, this is 1 1, and this is 1 2, and this is 2 0, 2 1, and 2 2. Okay. So now I can move in all the 8 direction. Okay. So to move in all the 8 direction, if you observe, if you go on this side, then it is x minus 1 and y minus 1. That is why we are doing x minus 1, y minus 1. If we are moving on the upper side, it is x minus 1 and y 0. So x minus 1, y 0. See this. Okay. If we are moving on this side, it is x minus 1 and y plus 1, which is this. Okay. If we are moving on this side, it is x 0 and y plus 1. Okay. X 0 and y plus 1. If we are moving on this side, it is y minus 1 and x is equals to 0. Done. If we are moving on the lower side, it is x plus 1, y 0. If we are moving on this side, it is x plus 1 and y minus 1. X plus 1 and y minus 1. If we are moving on this side, it is x plus 1, y plus 1. So this is how I am writing this array. Am I clear till this point? Just give me a quick 0 or 1. Just think of the scenario if I get irritated. I don't want respect or something. It's just that you respect other people, like what they might be going through. सर इतना तो ठीक करा था मैंने, पता नहीं आंसर फिर भी क्यों नहीं आया. ओके. Sir is missing in dy. Sir is missing in dy. संपदान सर से फर्स्ट क्वेश्चन नहीं कर पाए. What is missing in dy? Let me just see. What is missing in dy? No, nothing is missing in dy. Okay. So now we declare a visited array. Okay, to know if every range is covered or not. So we declare a 2D vector with every value as 0. Okay. This is just like declaring visited array of n cross n with every value as 0. But I didn't use array. Why? Because many a times an array of very big size behaves not what we have decided. So it's better that we use vector. Now we would start the iteration and we would iterate on the whole matrix. For in j is equals to 0, j is less than n and j plus plus. Okay. So now I would just say that if this is a Wi-Fi. Okay. So if a of I dash j is equals to 1, that it is an Wi-Fi. Okay. Then I would have a condition here. This loop would visit all the places for me. So I would say void helper. Okay. Here I would take the value of x and y. Okay, so value of x, or let's say ij, value of ij, because we are using ij here also. Then the given array only. Okay, like we don't require the given array, we can just have the visited array. Okay, so visited array, we can just have the visited array. Then let's have the this array also. Let's say we have this array also, we have the range of it. So how much range is left? So what is the range given? That is r. Okay, so if you observe here, like, let me just show you. Suppose we are 0 0 0 1 1 0 and 1 1. So if we are at this position, then we can't mark here, we can't mark here, we can't mark here. We can't mark anything outside the boundary. So that is why, to check if it is outside the boundary or not, we would say that if I is less than 0 or j is less than 0, okay, or j is greater than equal to n, or I is greater than equal to the value n. Okay, let's take the value of n also. Int I comma j comma n, int n. Okay, so if these are the condition, that if it is outside the boundary, then we would say just return, don't mark anything. Like boundary के बाहर हुआ तो क्या ही करना. Okay, this is correct. Then if it is within the boundary, then the control of the program is coming here, because if it was outside the boundary, then it had returned from that point only. So we would say visited of I dash j is equal to the value 1. We would visit it. Then we would visit in all the 8 direction. So we would say for int k is equals to 0, k is less than 8, and k plus plus. So now we would say new row is equals to I plus dx of k, and new column is equals to j plus dy of k. So we would just add the corresponding values, just like I showed you to visit all the 8 direction. Okay, after adding the corresponding values, we would pass it in the function, helper function. So I would say n r comma nc. Okay, the value of the n remains the constant, and then we would pass the visited array, and then I would pass the given array a. Okay, at this point it would be done. Okay, so now if this is a Wi-Fi, okay, we would say helper I comma j with the value of n. Okay, we would pass I comma j with the value of n. Then we have the visited array, and then we have the array a. Okay, after this is done, we would just check if every position is covered with the range or not. So now I would say for int I is equals to 0, I is less. So let's just copy this. Let's just copy this one, this one only. So now I would say if a of I dash j is equals to still 0, this is visited. This is, suppose we are not able to visit it. Visited array of I and j is 0, that it is still not visited after everything. Then we would return a false value. Else we would return a true value. If the control of the program is coming here, that means we didn't encounter a position where a false value is present. Somewhere I just wrote a wrong thing. Sorry, this would be this. This would be the condition, or so no matching parameters. for the value a comma r. It would be the range also, and here we would pass the range also. So we have the range, yes. Actually, I was not able to see because the range is outside. Okay. We found a new thing here. So let me just check for int I is equals to 0, vector int I is equals to 0, for int j is less than n, for int if a of I and j is equals to 1, then the helper function would start from ij and the given value is the value of n. Then we would have the visited array. Visited array is false with everything. For int I is equals to 0, I is less than n, then I plus plus. And here we have the jth array. We would return false at this condition. Here am I missing? If I is less than 0, okay. If I is less than 0 or j is less than 0, or g is greater than equal to n, or I is greater than equal to n, we would return from this position dx and dy. Int k is equals to 0, k is less than n. Like this dx and dy, I suspect this function a little bit. Any mistakes? Dx and dy comma is missing. Oh. Okay. Okay. Like any more mistakes, small silly mistakes that I'm doing. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 6, 7, 8. Okay. Fair enough. Dx of size 4. Dy of size 4. Let me just compare and run again. Why it is still giving me 4 int is equals to 0, I is less than n, j is less than n. Do we have like this array is n cross n only, no? Let me just see. The given array of 2D matrix of n cross n. Okay, this is correct. Any other mistakes you can find? You are passing line number 48. N R I N J, then n, then visited array A. I should have coded it earlier a little bit. Visited of I cross j. Anything else you can find? Any small mistakes? I cross j. I plus plus j plus plus. Today I'm making a lot of small silly mistakes. If I cross j, any more mistakes? Railway master sir ऐसे range -1. Okay, done. Okay, that is already visited. Hmm. Now let me just do a simple thing. Yep. It's better that I don't start finding silly mistakes. Processing result. Yep, this would be given. Yep. Okay, fair enough. So instead of finding small mistakes that I did, so just move forward with this. And this is the same one. Here we are passing the range again and again with -1, basically. So here also we are passing the start range, and here we are passing range -1. So if I just go here and I can say that range -1, and it would be done. Okay, here I don't need to pass. This is what was already there. So just showed you both the codes. Okay, range -1. Yep, this was what was there. Okay. Mhm. Instead of this, let's just use the combiner thing. That is the same one. Yep. Now tell me any issues if you have. Today I have a very bad day. Okay, so now I would stop the screen sharing. I would share the screen Chrome tab itself. सर ऐसे क्वेश्चन करके मैंग का सपना देख सकते हैं क्या? So I can't say absolutely man, but if you solve, like if this problem had a little bit higher constraint, that it was more greater than 4, then you can see the dreams of fan. So I didn't understand what's the matter with range. Base case IR is not written, not taken range correctly, range limit. Sir, इसका code दे दो. No issues. Can we do a second question using BFS? Yes, a bad day for sure. Yes, to be honest, it's a bad day. Live coding problem is not a joke. No, actually, what happens now? I am well accustomed with live coding. For the last 2 years, I have been doing live coding here itself. Okay, but sometimes when happens now, ki if you make a mistake during the initial phase, na, like in the initial phase, I forgot to share my screen during the live coding, so that got stuck into my mind. Okay, because I am also human. At the back end of my mind, I start also thinking. So at that point, I start making silly mistakes. And in spite of me telling you the correct variables and all, I can say that yes, this is not correct. This is like I'm saying you this is NCR and NR and NC, but still I'm passing NC comma NC. Because at the back of the mind, I'm thinking that oh, I made a mistake of not sharing my screen, and people started taking it a little bit negatively. I started getting a little bit of hatred. Okay, so what is the time complexity? Time complexity is the number of cells multiplied by 8 multiplied by 4. Because for one range, we are going in all the 8 direction. So for 4 range, we would be going 8 into 4. Sir, range नहीं समझ आ रहा है, code explain कर दो एक बार. Okay. Can you give the link of this question? I don't think you would be able to see the link. Why? Because if you observe, I have a problem preview thing. So I don't think you would be given the access. सर इसका कोड चैट में डाल दीजिए. Okay, let me just give you the code in chat. Anything else? Someone was telling me that he is not able to understand the range thing. I'm just a little bit afraid that last problem में ज़्यादा silly mistakes ना हो. थोड़ा आराम आराम से करेंगे आज. We won't rush it a little bit. Any optimization possible in this? Yes, a lot of optimization is possible in this if the range is more than 4. So let me first talk about you. Let me first talk about that. What is this range thing? So basically, range is nothing but, like, see, this is 0 0, this is 0 1, this is 0 2, this is 0 3, this is 1 0, this is 1 1, this is 1 2, this is 1 3, 2 0 2 1 2 2 2 3 3 0 3 1 3 2 and 3 3. So now see, if the range of this number is 2, that means that it would travel 1 and 2. 1 and 2. Okay. It would travel 1 and 2, 1 and 2, 1 and 2, 1 and 2, 1 and 2 in all the 8 direction. But let's say the range is 3. So this time it would travel like this. 1 2 3, 1 2 3, Okay, 1, 2, 3, and only 1 because we don't have anything else. Then 1, then this, then this, then this. Okay, so this is how, if the range is 3, this would be the scenario. If the range was 2, this would be the scenario. Let me just draw it in. This would be the scenario. This is how the range thing is popping up. Do I make sense to you? What was that person? Uh, 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 Please show. Someone. आशीष गोयल. Am I clear to you, आशीष गोयल? जरा जल्दी बताना भाई. The time complexity is big of n into n. Yes, absolutely. सर समझ नहीं आ रहा, कोड एक्सप्लेन कर दो. सर रेंज समझ नहीं आ रहा. Okay, आशीष गोयल, just give me correctly. Code is given. Sir, you cannot decide yourself. You're also okay. Yeah, thank you. Please show line number 42 till the end. Line number 42 till the end. Yep, this is. You can just read it from the given chat itself. Any optimization possible in this? Yes, an optimization of you using multi-source BFS is possible in this. Can we use BFS here? Yes, absolutely, you can use BFS. Last is easier. Yes, last. This is also easy, to be honest. Can anyone explain the test case 1? I would explain. Yes, we can use. Yes, I would explain the test case 1, but I would need a chocolate from you. So this is the second time I'm explaining the first test case. Because why I am explaining him explicitly? Because someone explaining him in the chat would be a little bit difficult. No one can explain a little bit matrix problem in the chat. So that is why I tried to explain him explicitly. It's not that I know him personally or something. Okay. So now see, matrix is given as 0, 0, 1, 0, 0, 0. This is 1, 0, 0. So if the range is 2, then from this Wi-Fi, we would visit here 1 and 2, 1 and 2, 1 and 2. We don't have anything here. Okay, we don't have anything here. Here and here we don't have anything. So we can't visit same thing here. So 1 and 2. Every Wi-Fi would have the same range. 1 and 2, 1 and 2. We don't have anything other than this. After this, we have this which does not cover the range of the Wi-Fi. We have this which does not cover the range of the Wi-Fi. That is why the answer to this is false. A chocolate or a comment from you. So basically, I don't need chocolates and all. To be honest, I don't like chocolates. Just give me a comment and that would make my day. Okay. Sir, we want chocolates. Le lo bhai. Just send me the address on LinkedIn. I would deliver a chocolate to you. Sir, please explain the range of 3. Chalo. दिन सही नहीं है. So let me just explain it here. So see, 0, 0. Okay, let me just take a screenshot then. This person has written this much big test case. It's like I should explain him this test case also. 1, 2, 3, 4, 5. And this is 1 at this point, 0, 0 at this point. This is everyone 0 at this point. And everyone 0 at this point. Okay. So this is 1, 2, 3, 4, 5. So we have 0, 0, 1, 0, 0. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes. Now see. So the range is 3. So it would cover this 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. but all this are not covered. See, all this, the values, let me just make this, these all values does not cover this range. So that is why the answer to this would be false. Okay, you did the hard work of giving me this long test case. I did the hard work of explaining this long test case. I made justice to myself. Okay. Sir, what if range is less than 0? Range would never be less than equal to 0, because range is at most is equals to 0. What is my LinkedIn profile? This is my LinkedIn profile. Yes, absolutely. Sir, what's wrong in this code? It means that the Wi-Fi is not working. Exactly, faulty Wi-Fi. Yes. Answer will be 1. If n is equals to 5, range is equals to 3, it won't give 1. It won't give 1 because it is clearly told that given in the 8 direction. So if you go back to this, okay, if you go back to this, we have covered all the 8 direction. This is first direction, this is second direction, this is third, this is fourth, this is fifth, this is sixth, this is seventh, this is 8. After even visiting all the 8 direction, we can't visit this. We can't visit this. We can't visit this. So the answer would be false, not true. And I'm very sure of that. Do I make sense? As each level of recursion 8 direction. Wi-Fi just don't travel linearly. No, bro, it is not that. Expected output is 1. It shouldn't be the scenario. Let me just see. If the expected output is 1, then the answer is a little bit wrong. Because we are visiting in all the 8 direction. Yep. So let me just see custom input. So range is equals to 3 and the value is, let's say, 5. 0 0 0 0 0 1 2 3 4 5 1 2 3 4 5, then 0 0 1, then 0 0, and this answer would be 0 0 0 0 0 0 0 0 0 0. Now let me just check this, compile and run. It is propagating recursively. Entire office or not, the office is inspired, indicating the location. In addition, a ranger is given to cover it in Alex and remind that independent office also. Your task is to cover the entire office or not. Okay, okay, yeah. Okay. So it's truly cover. Yup. I forgot to mention. Yup, see. So this problem is telling me that, yes, I remember that when I read the question, I remembered. This is telling me that if this is a Wi-Fi and its range is 3, then it would come here and it would cover this. Then this would start covering, which is not mentioned in the question. It is just telling me that this Wi-Fi has a range or something. But if it is not even practical, that if there is a Wi-Fi at my home and it has a range of 2, then from here the range is again 2, from here the range is again 2, from here the range is again 2. This is not even practical, to be honest. This question is wrong. Either this question has not mentioned, either this has not mentioned. Yep. So there should be condition, it should be visited also. Yes. Yes. So this question is wrong. It is not telling us that recursively after visiting a particular point, it is visiting all the 8 points. This question is wrong. That if a Wi-Fi covers a particular position, then this covers the range again. This is not mentioned. I forgot to mention you that. The last question is a little bit, like I can say, it might be difficult if you don't know about Khan's algorithm. If you know about Khan's algorithm, so this is basically related to. Okay, first let me introduce this problem. First, tell me if I'm clear with this or not. Sir, it will cover in all direction. Then how to make conditions for each 8 direction? If it covers linearly for 8 direction, then you can just go in all the 8 direction from that point and you can use that. It's a very, as I said, range is fucked up. It's a very hard problem. Yep. It should not be visited also. Yep. No, in spite of being visited or not visited, it doesn't matter to us. Yep. आज दिन सही नहीं है यार. To be honest, the questions are also wrong, and I'm also going a bit wrong today. I don't know why. Okay, this question. See, am I displaying my board? Yes. So this question tells us that there is some task that is there. Okay, it is telling me that let's take a scenario that let's say that I want to marry a girl. Okay, I want to marry a girl. Let us first understand this analogy. I want to marry a girl. To marry a girl, what I need to do is I need to first entice her, okay, or I can say impress her. Then I need to impress her friends also, okay. Then I need to impress her family also, so that I can marry her. After that, I would be able to marry her. So there is a list of dependencies that I need to do. Okay. If I don't entice her, then I can't directly go and know her family. If I don't know her, then I can't directly go to my friends. So this ordering needs to be followed. Okay. Whenever you have a connection kind of thing where a dependency also exists, whenever you have a connection kind of thing and a dependency also exists, then the very first thing that should pop in your mind is topological sorting. What is topological sorting? Topological sorting tells us a way to just complete all the tasks, completing all the prerequisite. To complete, to like the prerequisite of impressing that girl would be selecting that girl. The prerequisite of making friends with that girl's friend would be to impress her, and after impressing her family, then only I can move to her family. So topological sorting tells me a particular path in which I can complete those tasks. Okay, so whenever you have a list of connections and a dependency, the first thing it should hit in your mind is topological sorting. If you don't know topological sorting, then consider learning from here. Topological sort. Consider learning from here. The last question is based on Khan's algorithm of topological sorting. Yes. Yep. Now let us move back. So now in this way, we are told that two modules can be simultaneously processed. What is simultaneously? At the same time. Two modules can be processed at the same time if there is no dependency between them. Okay. So it is telling me that 5 has a dependency over 2. 5 has a dependency over 0. So the graph would kind of look like this. The dependency graph would kind of look like this. Let me just show you this, how this graph is popping up. So 5 has a dependency of 0. See, 5 has a dependency of 0. 5 has a dependency over 2. 5 has a dependency over 2. 4 has a dependency of 0. It's there. 4 has a dependency of 1. It's there. 2 has a dependency of 3. It's there. 3 has a dependency of 1. It's there. Okay. So now way to complete this can be that initially 5 and 4 has no dependency. So I can start 5 and I can start 4. And what is the time required? The time required is this. Okay, so this is the time required to complete the first task, second task, third task. This is second, this is third, this is fourth, this is fifth. So am I presenting my screen? Yes. So now see, 5 के ऊपर कोई डिपेंडेंसी नहीं है, 4 के ऊपर भी कोई डिपेंडेंसी नहीं है. So we can start 4 and 5 simultaneously. What do you mean by simultaneously? That two modules can be done at the same time. So now doing 4 and 5 would require how much time? Doing 4 would require 3 amount of time, and doing 5 would require 2 amount of time. See, 3 and 2. So after a time period of 2, I can start with a new thing. So I would start off with this 2 only. Okay. So I can start off with this 2, which is 1. So now I can, after 5, I can go to 2, which would require a time period of 1. So in a time frame of 3 minutes, 5, 4 and 2 would be done. 5, 4 and 2. Why 5, 4 and 2? 2 require 1 unit of time. No, 2 require 3 unit of time. Sorry. Yep, 2 require 3 unit of time. Yep. 2 require 3 unit of time. 2 is requiring, let me just write it a little bit clear. Yep. 2 requires 3 unit of time. Okay. So 2 plus 3, we are running this timeline. So suppose after 3, 4 is completed. So after 4, you can move back to 1, which would require how much unit of time? 1 would require 2 unit of time. So in a time frame of 2 plus 3, in a time frame of 5, I was able to complete 5, 4, 2, 1. See, 5 and 2, which would require 2 plus 3, 4 and 1, which would require 3 and 2, which is again 5. So in a time frame of 5, I am doing 2 tasks simultaneously, which is already given. Okay. Now what is left? 0 and 3. Okay. So after completing 0 and 3, 0 has no dependency from 4 because 4 is done. 0 has a dependency of 5. 5 is done. So now 0. I can complete 0. So 0 requires 1 unit of time. Okay. So I will just write here 0, and it would require 1 unit of time, and 3, which would require 2 unit of time. Okay. That is why the output to this is 8, if you observe. See. So from 0, module 5 and 4 are processed if they have no dependency. 5 and 4 is processed if they have no dependency. Module 5 finishes the processing at time 2, so allowing module 2 to begin processing at the same time. So module 2 has begin processing at the same time after 2 minutes. Then module 4 finishes processing and module 0 begins processing. So after module 4, module 0. So instead of this is there. So just like we can just change the ordering also. Okay, that is why this output is there. And this is the explanation of this. So it is just like complete all the things which don't have a prerequisite and then complete that. Okay, it is just like this, that let's say that, let me just draw this graph. Okay, now you would understand. See, 4 has no dependency. So I would complete this 4. I would complete this 5. I would complete this 4 because they don't have any dependency. If this is done, then this does not exist. This does not exist. This does not exist. This does not exist. Okay. Now 2, 0 and 1 don't have prerequisite. Okay. So now you can do anything. Either you can do 0 also at this point, and then 2 does not have any dependency now because 5 is done. So now you can do 2 also, 1 also. If 1 is done, so 1 has a dependency. Okay, 1 has a dependency of 3. Remember this. So if 2 is done, then this is done. So 3 is left. 3 does not have any dependency, so we would do 3 and this would be out. So we are left with 1. So now let me do this again. Okay, now see. What I can do is, so now let me just write it down with the names also, like what is the name? 1 2 3 1 3 2. 1 2 3 1 3 2. 1 2 3 1 2 3 and 1 3 2. 1 3 2. This would let us understand very well. So see, 5 and 4 does not have any dependency. So I can take up this 5, I can take up this 4. And how much time would it require? It would require, 5 would require 2 unit of time, 4 would require 3 unit of time. So after 2 unit of time, 5 is completed. So if 5 is completed, then we would remove this, we would remove this, and we would also remove this. Okay, so now which figure is there which does not have a dependency? 2 is there which does not have a dependency. So after 5, I can move forward to 2, which would take 3 unit of time. So 2 is done. So now any other, so after 3 unit of time, 4 would be done. So after 4 is done, after 4 is done, 0 would be there. Okay, or let's say 1 would be there because 1 has also not dependency. So 1 would be there. Anything, you can go with 0 also, you can go with 1 also. Okay, so now after 5 unit of time, both are done. 5 2 4 1. 5 2 4 1. This is done. Now I can move to 0 also and I can move to 3 also. So let's say I move to 0. Okay, and I can move to 3. This is how we are doing it. Okay, do I make sense? Just give me a quick 0 or 1. Are you reading the dependency other way around? Yes, just the other way around. Okay, am I clear with the dependency thing? First, complete all the task which does not have a prerequisite. Then complete the task which, like, after, like, see, if I'm done with proposing my girl, then next time I would be in a relationship. So first I need to complete the prerequisite of proposing my girl, then we can be in a relationship. Do I make sense? Just give me a quick 1. What are the number of live viewers? Okay, it seems that it is way very less. I would just move forward. Like, do we have anyone like replying to this? Mhm.
Enroll in trade, your first step in trade.
Okay, no one. Okay, so now we can just use Khan's algorithm here. Khan's algorithm tells us that if if the we would just calculate the number of in degree and out degree. What is in degree? In degree is the number of nodes coming to that node, and out degree is the number of nodes going out from that node, and degree is the sum of in and out. So I can say that degree of a node is in plus out, and in out degree is nodes coming to that node. So what is Khan's algorithm? I would just explain it in brief. So Khan's algorithm. Mhm. Mhm. Khan's algorithm for topological sorting. So Khan's algorithm, so DFS based solution in the way. Yup. So Khan's algorithm is just this. Okay. So let me just explain you what is this. Okay. So Khan's algorithm tells us that we first compute the number of in degree. Okay, like let me just show you how this graph would pop up, like how we can get the topological sorting of this. Mhm. Okay, compute the in degree for each of the vertex of the directed acyclic graph. This is the meaning of that, and initialize the count of visited node as 0. So let us count the number of in degree. So 0, 1, 2, 3, 4, 5. So in degree of 0 is 2. 2. In degree of 1 is how much? 2. In degree of 2 is 1. In degree of 3 is 1. In degree of 4 is 0. And in degree of 5 is also 0. So what is this? This is basically the number of nodes coming to that. This is in degree and this is the particular node. First we compute the in degree. And number of visited node is 0. This is how Khan's algorithm works. Okay. So now see how we are doing that. So first we pick all the nodes with the degree as 0, that is 4 and 5, and add them to the queue. So this is basically a queue. So we would add 4 and 5 to the queue. Okay. Now remove a vertex from the queue and then. So I would just tell you what is then. So this is 4. So I would write here 4. Okay. And then all the nodes, whatever 4 is, all the out degree from 4, I would subtract 1 from it. So 4 has an out degree to 0, so I would subtract 1 to it. 4 has an out degree to 1, I would subtract 1 from it. Okay, and then I would say this is 4. And now I have 5. So 4 is now done, 4 is processed. Now I have 5. So 5 has an out degree to 0 and 2. So 0 minus 1, which would make it 0. So if a particular in degree of 0, in degree of a node becomes 0, अगर किसी भी node का in degree 0 हो जाता है, add it to the queue. Okay, add it to the queue. Then 5 has also an out degree to 2 also. So just subtract 1 from it, which would make it 0. So now we have 2 also. 5 is done. So after 4, we have 5. Okay. So now we would remove this 5. Then 0. 0 has no out degree to anyone. So we would simply write here 0. Okay. Now we have 2. 2 has an out degree to 3. So we would subtract 1 minus 1, that is 0. The in degree of 3 becomes 0, so we would add it. And then 2 is now processed, so we would write here 2. 2 is now done. So now 3. So 3 has an out degree to 1. So we would just subtract it. Then we would write it. 3 is processed. We would write it. 3 is now done. Next thing we are left with 1. 1 has no out degree to anyone. So now we would run. So the topological sorting of this is this. We can visit 4 and 5. Okay. We can visit 4 and 5, then 0 and 2. Then we can visit 3 and 1. So this is how Khan's algorithm works. Basically, Khan's algorithm uses the property that if the in degree is 0, then we can start from there. If a particular thing has no prerequisite, okay, we would complete that task, and all the tasks which are dependent on that task, we would remove the dependency from that. Translating the same in Hindi would be टोपोलॉजिकल सॉर्टिंग खान्स एल्गोरिथम इस बेसिस पे वर्क करता है कि जिस टास्क का कोई प्री रिक्वेसाइट नहीं है उसे पहले खत्म कर लो, और जो जो टास्क इस टास्क के ऊपर डिपेंडेंट था उस पे से डिपेंडेंसी सब्ट्रैक्ट कर दो. अगर उस कोरेस्पॉन्डिंग नोड का प्री रिक्वेसाइट 0 हो जाता है, देन ऐड दैट टू द क्यू. दिस इज व्हाट इज खान्स एल्गोरिथम इन जनरल. Am I clear with the Khan's algorithm at least? If we move away from our outer power of the node, then its power would be 4 minus 3, that is 1. Here I got one order. Outer than is given as a range, but the areas will have what? If it is routed, then it is a full power given as a range, but other areas will have the power. What is the range there? No. So am I clear with the Khan's algorithm at least? There are more than 30 people at this point of time. Can you tell me a little bit quick? I didn't even have my dinner till this point. So let me just see the YouTube, because sometimes I see a little bit late response from here. So am I clear with Khan's algorithm? Okay, so now we can simply use this Khan's algorithm to solve this. Okay, so now what we can do is, here the only problem is that this line, this is the problem, that we two modules can be processed simultaneously. This is very important. So now what we would do is, we would process two modules and we would take the maximum of that at the end. So we would have a DP array kind of thing, where from each we would take, like we would do this same algorithm only. We would first calculate the in degree, we would make a graph, we would calculate the in degree, and then we would just process two modules at a time, and this is done. Okay, so now let me just code this. Let me first add up the in degree and make a graph. Okay, first let us do this. Duration would be D and dependency graph would be, let's say, A. Okay, so now I can say I have a vector of integer where the graph, okay, graph has n itself, and then I can say that vector int degree of size n with every, initially degree is 0 for everyone. Okay, now I would say for auto e dash a. Okay, for auto e dash a, then I would say g of e dash 0 dot pushback. push back E of 1. Okay. And see, in degree, we are calculating the in degree. So if there is a path from 5 to 2, 5 to 2, so the in degree of 2 would increase. So the in reality, the in degree of E of 1 should increase. So I should say degree of E1 should increase by 1. Okay, and we would do this. So we have calculated all the in degree, and then we would initialize a Q. Okay, then we would just declare answer. Okay, answer of n comma 0. Okay, then we would say the number of count. Why? Because if all the nodes are visited in Khan's algorithm, then we can say that this is done. So now we would initialize for int I is equal to 0, I is less than n, and I plus plus. And if the in degree is 0, we would initiate, like all the tasks which don't have a prerequisite, we would insert it to the queue. So if degree of task I is equals node I is equal to 0, then q dot push the current I. Okay, of the in degree is 0, then we would push it. Then we would start the simple DFS while the queue is not empty. Like we did this till the point the queue had no elements. We did this till the queue has no elements. So we would do this also. We would take out the front of the queue. So we would say int node is equals to queue dot front. Okay. Then we would remove that from the queue. And as we got a current node, so we would just do C++. Okay. Yep, C is not declared anywhere else. So now I would visit the adjacent of that particular node. Like suppose वो task हो गया, तो वो जिसके ऊपर dependency थी, we would subtract 1 from it. Okay. So now I would say auto neighbor of G of this particular node. Auto neighbor G of this particular node. Okay. Now we would subtract 1 from all the other nodes. Like वो task जिसके ऊपर dependent था, we would subtract 1 from it. So we would do minus minus of degree of this particular neighbor. If after subtracting 1 from it, it becomes 0, that it has no prerequisite now, we would just insert it to the queue. Queue dot push. Okay. I would say this task has no prerequisite, so I would just insert this. Now there comes a little bit of tricky part at this point. So as we have initialized the DP array, not the DP array, the answer variable with n is equals to 0. What is the significance of this? Here we are just calculating the maximum of both. See, maximum of 2 and 3, maximum of 3 and 2, so that we get that 2 tasks we are able to do simultaneously. Okay. So at this point of time, we would say dp of this particular neighbor is equals to max of whatever was already there or the max of this particular node, okay, plus, okay, let's make it dp only. dp of this particular neighbor, dp array of this particular neighbor is equal to dp array of this neighbor current node plus the dp, like this is the duration array, yes, the d array of this particular node, the duration of whatever all are already there, and the dp array of this. After this is done, at the end we would just have the sum of it, like we would have the maximum value. Why do we need the maximum value? Let me just tell you that also. Suppose I can do 2 tasks at once, and one task requires 5 units of time, second task requires 2 units of time. So I would require 5 units of time to complete both the tasks. Why? Because 5 is maximum here. So in the same manner, I would say initialize and mx is equals to -5. Now I would say if I'm able to visit all the nodes, if I'm able to visit all the nodes, then only a topological sorting exists. If I'm able to visit all the nodes, then I would start finding the maximum value from 2. For int I is equals to 0, I is less than n, and I plus plus. And I would say mx is equals to max of mx, comma, dp of I plus d of I. Okay? And I would just return mx. Now let me just see how many errors am I making. Okay. Okay. I thought that this time also I would make silly mistakes, but I took it very slow. I took the pain of making you understand Khan's algorithm so that this should be clear. Because apart from Khan's algorithm, this was just using the maximum value out of both. This was just this. So this was just by using Khan's algorithm. If you already know Khan's algorithm and topological sorting and are already acquainted with graph, then this would have been very easy. So I took the pain of completing the prerequisite. So now let me just, now you just tell me the line number at which you are not able to understand. And this is done. So could we first create adjacency list, then we can calculate the in the help of list? Yes, we can do either of the ways. But while we are just creating the graph only, we can just declare the list here only. The Vyanchu CS202004, am I clear with the line number 18? Because there we are calculating the degree. I stuck where last module having degree, my code was not working for both condition, last module art degree or not. Last module has an out degree. Last module has an out degree. What is the last module here? So what was the last module here? The last module here is 1. So if it does not have an out degree, it shouldn't create a problem. Not working for that degree, have an out degree or not. So we only need to care about out. Now tell me the line number at which you were not able to understand. So now the last problem, like I stumbled a little bit on the second problem where I started making a small bit of silly mistakes, but the algorithm was told absolutely correct. The only problem that was there with the question was that it was not told that we need to do that recursively from that current point. This was a problem with the problem setter, not me. Okay, this was not mentioned in the question. The very first thing. The very next thing was this project manager thing. So project manager thing uses Khan's algorithm. This is a good question, to be honest. And like uses Khan's algorithm, I took the pain of explicitly explaining you Khan's algorithm, which was just a prerequisite. And the first problem was a little bit easy. Okay, so I don't see any queries even in this 30 seconds. So I will turn off this session now. So if you were able to gain something out of it, make sure you mention that in the comments. If you found out some mistakes of mine, make sure you point out those two in the comments so that I won't repeat it and I would become better. So that's it for today. Thank you and have a nice day. So if you're watching this stream in the recorded version, feel free to like and comment on the video so that the reach of this video could be increased. And all the folks which were here till this point, just wait 1 minute more, let the stream end, and you can just comment and like the video so that the reach of this video could be increased and this work could be justified. That's it for today. I'm going to have my dinner. Make sure you have yours too. Thank you, everyone.